Dear students, in our last lecture we have completed all theorems related to the derivatives of an inverse functions. Means in that we have studied the derivatives of some standard inverse trigonometric functions. Also we have solved some uh, derivatives related to that concept. Today also we will see some examples uh, to get the derivatives of some functions. Okay, but before that we will revise the concept, that is allied angles formulae, which are very useful to get the derivatives of inverse trigonometric functions. Okay, so let us see allied angles formulae. Now what is the meaning of allied angles? You know that if sum or difference between any two angles is in integral multiple of pi by 2, then the angles are said to be allied angles. Integral multiple of pi by 2 means n into pi by 2. So in 11th standard we have studied the meaning of or definition of allied angles. Today we will revise the allied angles formula. So let us see first formula. Here it is sin pi by 2 minus theta is equal to cos theta. See, this is the formula which is called as allied angles formula. Now see, uh, if you use pi by 2 means pi by 2 minus theta is allied angle with this theta, means theta and pi by 2 minus theta is a pair of allied angles whose sum or difference is pi by 2. So if you want to convert sine ratio to cos ratio, then always you have to use sin pi by 2 minus theta is equal to cos theta. Pi by 2 means it is 1 into pi by 2, means odd multiple of pi by 2. You know that in case of allied angles we have studied the even multiples of pi by 2 and odd multiples of pi by 2. If the difference or sum is even multiple of pi by 2, then ratio does not changes. Or in case of odd multiples of pi by 2, ratio changes, means sine changes to cos. So sometimes if you want to change the sine ratio to cos ratio, then we have to use sin pi by 2 minus theta is equal to cos theta. And this angle pi by 2 minus theta lies in first quadrant. Okay, so in first quadrant all ratios are positive. So this is first formula. Then cos pi by 2 minus theta is equal to sin theta. Just revise this concept. Then tan pi by 2 minus theta is equal to cot theta. Cot pi by 2 minus theta is tan theta. Sec pi by 2 minus theta is equal to cosec theta. And cosec pi by 2 minus theta is equal to sec theta. So here if you see these two formulae, then sin changes to cos or cos changes to sin. Here tan changes to cot or cot changes to tan. Then sec changes to cosec and cosec changes to sec theta. So always remember, if you take pi by 2 minus theta, then ratio changes. Means if you take odd multiple of pi by 2, here it is 1 into pi by 2. Okay, so all these are allied angles formulae, okay, which are useful to find out the derivatives of an inverse trigonometric functions. Okay, now let us see one note that we have to remember is here. Just I have explained that pi by 2 minus theta lies in first quadrant, hence all ratios remain positive. We know all about this. But if we use pi by 2 plus theta, which lies in second quadrant, suppose if you use pi by 2 plus theta, then that angle, means this angle, lies in second quadrant. Then what happens? Then sin pi by 2 plus theta and cosec pi by 2 plus theta remain positive. See, here we use sin pi by 2 minus theta, which gives cos theta, but sin pi by 2 plus theta is also positive because sine ratio is positive in second quadrant. See here, pi by 2 plus theta lies in second quadrant. So sin pi by 2 plus theta means this is a sine ratio, and we know that in second quadrant sine ratio is positive, so sine pi by 2 plus theta is also positive. So sine pi by 2 plus theta, and similarly cosec, because cosec is a reciprocal of sine ratio, so cosec pi by 2 plus theta is also positive. So what happens? Hence we get sine pi by 2 plus theta is also cos theta. Just like here, sine pi by 2 minus theta is cos theta, like that sine pi by 2 plus theta is also cos theta. Similarly, cosec pi by 2 plus theta is also sec theta. But as a if you want to use this for derivative, then, but in general it will be convenient to use above formula only. Means you just remember that sine pi by 2 minus theta is equal to cos theta. Okay. Also you remember that sine pi by 2 plus theta is equal to cos theta, but for our purpose you just remember this formula. Okay. So remember, for other ratios it is not possible. Suppose if you think about cos pi by 2 plus theta, then it gives minus sin theta, because pi by 2 plus theta if you take here, then pi by 2 plus theta lies in second quadrant, and in second quadrant cos ratio is negative. So cos pi by 2 plus theta gives minus sin theta. So that will be another formula. But in case of sine or in case of cosec, if you use pi by 2 plus theta here or here, then you will get same answer. Means here you will get cos theta, and here you will get sec theta. Okay, but we will remember all these 6 formula. Okay, now let us see example of derivative. So let us study some important derivatives of inverse function. Okay, find dy by dx. Now see this example number 1. If you want to differentiate y is equal to sine inverse cos 3x. Similarly, if you want to differentiate y is equal to cos inverse sine 3x. Similarly, third example is y is equal to tan inverse cot 3x. Then y is equal to cot inverse tan 3x. Then y is equal to sec inverse cosec 3x. And last one, y is equal to cosec inverse sec 3x. Now see all these 6 examples. See, in this case, here it is sine inverse function, and in bracket it is given cos 3x. Composite function is there. Here it is sine inverse and it is cos here. Here cos inverse, then here it is sine. Here tan inverse, then here it is cot. Cot inverse, then tan. Sec inverse, then cosec. Cosec inverse, then sec. Okay, so there is a pair sine cos, cos sine, tan cot, cot tan, sec cosec, cosec sec. Then what is our trick here? First of all, we have to simplify this by using trigonometric formula. Now when there is a sine inverse, okay, and here it is cos 3x, then try to find out here, or try to convert this cos into sine ratio. Means see, in all these type of examples we have to convert sin x to cos x, or cos x to sin x, or tan x to cot x, or cot x to tan x, sec x to cosec x, and cosec x to sec x. Okay, so for that we require that allied angle formula. Okay, so here we will use allied angles formula with the angle pi by 2 minus x. Okay, see here, I will solve one example. There are 6 examples, but I will solve one example for this. Then you will get idea about this. Now in this case, if you observe all these 6 functions that we have to find out the derivative, then after this procedure you will get dy by dx is equal to minus 3 always in all cases. Okay, we will see one by one example, we will see this in detail. Okay, so let us see one example. Find dy by dx. Just I have taken that first example, y is equal to sine inverse cos 3x. Now our purpose is, our main part is, we have to convert this cos ratio to sine ratio. Okay, so for that, let's see the answer. First of all, we will write given condition, given function here. Now see how will you convert it. This is sine inverse as it is, in bracket sine pi by 2 minus 3x. Cos 3x can be written as sin pi by 2 minus 3x, because we know that sin pi by 2 minus theta is equal to cos theta. So by that you will get this. Okay, now what happens from this, we will get the simplification because it is sin inverse of sine. So just you will get pi by 2 minus 3x, because sin inverse of sin x is x. Okay, now this is very simple to differentiate. So hence we get differentiate with respect to x, and we get dy by dx is equal to 0 minus 3. 0 is the derivative of pi by 2, it is constant, minus 3 as it is, and derivative of x is 1. Hence you will get the answer minus 3. So in all cases, in that all cases, 6 cases, you will get the same answer, dy by dx is equal to minus 3, because always you have to convert, always we have to use the angle pi by 2 minus 3x in that case. Okay, in all that 6 cases you will get dy by dx is equal to minus 3. Now there is an alternate method. Okay, let us see. In case of this, you can use this angle also, pi by 2 plus 3x, because sin pi by 2 plus theta is also cos theta. Just we have discussed that formula. So sin inverse of sin pi by 2 plus 3x, if you use this formula, then the simplification will be this, and by differentiating you will get plus 3 answer. But in case of sine ratio it is possible, or in case of cosec ratio it is possible, not for tan cot. So this is the alternate method for in case of only sine ratio, means sine inverse function is given to you, and in bracket if it is cos 3x, then you can use sin pi by 2 plus 3x also, because sin pi by 2 plus or minus theta is equal to cos theta. So you can use this for only sine ratio. Okay, not in general for other ratios. So for that, to remember this, you take only this combination, means you take the angle pi by 2 minus 3x only, then you will get the common answer, dy by dx is equal to 0 minus 3, that is equal to minus 3. Okay, now we will study, we will revise the double angles formula. Okay, now first formula, you know that sine 2 theta is equal to 2 sine theta cos theta. Cos 2 theta is equal to cos square theta minus sine square theta, or you can write 1 minus 2 sine square theta, or 2 cos square theta minus 1. Original formula is cos square theta minus sine square theta. If you put cos square theta as 1 minus sine square theta, you will get this formula, or if you put sine square theta as 1 minus cos square theta, then you will get this formula. Okay, so cos 2 theta, double angle formula. Here double angle converts to single angles. See, 2 theta becomes theta. Similarly, you can discuss for half angle also, theta becomes theta by 2, and so on like this. There is another formula, sine for sine 2 theta, that is 2 tan theta upon 1 plus tan square theta. You can prove this by using this basic formula. Okay, and another formula for cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. Here cos ratio converts to tan ratio, here sine ratio converts to tan ratio, and tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta, like this. So all these are very well known formulae, means all are called as double angles formulae. Now these formulas are also very important to get the derivatives of an inverse trigonometric functions for simplification. Okay, so let us see some examples related to this. Find dy by dx if, suppose this function is given to you, y is equal to cos inverse in bracket 1 minus 2 sine square x. Now always remember, when there is cos inverse, and if you want to simplify this function by using trigonometric rules, then try to find out cos ratio here. Then cos inverse cos x becomes x, so like that. So here if you know that double angle formula, then this can be written as cos inverse, and this is direct formula, that is cos 2x. Okay, so simplification is possible here. So just you will get cos inverse cos 2x, and that is equal to 2x. Okay, now this is very easy to differentiate. So differentiate with respect to x, and hence we get dy by dx is equal to 2. Similarly, if you have another example like this, y is equal to cos inverse in bracket 2 cos square x minus 1, then this is also formula for cos 2x. All of you know this. So simplification is same, cos inverse cos 2x, and hence you will get 2x. After differentiating, you will get dy by dx is equal to 2. Okay, so compare this. Let us see the comparison. Okay, so here what is our main part? You have to remember the double angle formula for cos ratio. If you know this formula, then this is very easy to simplify. Okay, so remember these two examples. Here it is cos inverse, and in bracket this expression is given, and it is a direct formula for the cos 2x. Similarly, here is 2 cos square x minus 1, and you have this formula. Okay, so let us see the comparison. Okay, very simple questions like this that we have to solve, but related to double angle formula. Okay, now let us see another example also. Suppose it is given that third example, y is equal to, here it is sine inverse ratio, and in bracket this function is this expression is given to you, 1 minus 2 sine square x. Now in answer, how will you simplify this? See, sine inverse, this is the formula for cos ratio. Do not write sine 2x here, because this is the formula for cos ratio. Remember, don't get confused here. You remember that 1 minus 2 sine square x is cos 2x. Here it is sine inverse. Okay, sine inverse cos 2x. But now you know that if it is sine inverse, then you have to convert this cos ratio to sine ratio. And if you want to convert cos to sine, then what will you use? You will use this formula, sine pi by 2 minus 2x or sine pi by 2 plus 2x. I have taken it together, plus or minus. You can take any one of that, pi by 2 minus 2x also, or pi by 2 plus 2x also. Okay, but I have given this together. Okay, because the conversion is possible for pi by 2 minus 2x also, and pi by 2 plus 2x also. Okay, so that's why you will get this pi by 2 plus or minus 2x. And now after this simplification, you will get differentiation. Differentiate with respect to x, and dy by dx is equal to plus or minus 2. Okay, so remember this example also. There is a sine inverse function, but in bracket it is a formula for cos 2x. Okay, so this combination is also possible. So for that it is given here. And fourth one example, that is y is equal to sine inverse 2 cos square x minus 1. Here in this case also you will get this simplification, sine inverse cos 2x. Again we have to convert this ratio like this, cos to sine, sine pi by 2 plus or minus 2x, and you will get this simplification. Then differentiate with respect to x, and you will get dy by dx is equal to plus or minus 2, or you can write plus 2 or minus 2 depending on this formula. Okay, so remember all these examples. These are the some examples related to allied angle formula or double angle formula. We have to study more examples like this. Okay, more different types of examples in our next lecture also. But today you study all these examples which are very useful, which are very important, related to trigonometric formula, means allied angle formula and double angle formula. So try to solve this type of questions related to the inverse trigonometric functions. Okay, thank you.